Sir, we'll start, sir.
Yes, sure. I'm ready.
Okay, sir. Fine, sir. 2 minutes. Dear participants, warm good evening to everyone gathered here for this public outreach event. This is the first of a series of showing a way as how one can integrate technology in the classrooms to make things more attractive to students, teachers, parents, and peer-to-peer learning, student interaction, teacher interaction, and so on. Today's talk is about Ramanujan, the inspiration story, and the glimpse of his mathematics. The speaker is Professor Ken Ono, Thomas Jefferson Professor of Mathematics, University of Virginia, USA. He received his doctoral degree from University of California, Los Angeles, and considered to be an expert in the theory of integer partitions and modular forms. Professor Ono is a passionate and award-winning mathematician who is well-known number theorist. He is Vice President of American Mathematical Society. Professor Ono's contribution includes several monographs and over 160 research and popular articles in number theory, combinatorics, and algebra. In 2014, Professor Ono and his collaborators published a great result in algebraic number theory that generalized one of Ramanujan's own results. Professor Ono's work, which is based on pair of equations called Rogers-Ramanujan identities, can be used to easily produce algebraic numbers such as pi, better known as golden ratio. Professor's work on mock theta function was elected by Discover magazine as the second best scientific work of the year 2014. He has held numerous positions earlier and also served on the editorial boards of numerous reputed journals specializing in number theory. He has received many awards for his research in number theory, including Ivanham Fellowship, a Packard Fellowship, and Sloan Fellowship. Professor Ono was awarded for his early career award for science and engineering by former President of USA, Bill Clinton, in the year 2000. He was named the National Science Foundation Distinguished Teaching Scholar in 2005. But apart from being a great mathematician, he will hopefully tell us in his talk why he is a great devotee of Ramanujan. Srinivas Ramanujan, one of the most inspirational figures in the history of mathematics, was a poor gifted mathematician from lush South India who left behind 3 notebooks that engineers, mathematicians, and physicians continue to mine today. Born in 1887, Ramanujan was a 2-time college dropout. He could have easily been lost to the world, a thought that scientists cannot be to absorb. He died in 1920. Professor Ono will explain why Ramanujan matters today and will share several clips from the film The Man Who Knew Infinity, starring Dev Patel and Jeremy Irons. Professor Ono served as an associate producer and mathematical consultant for the film. He has got a fascinating story to talk about, fascinating story to say about his own work and how it measures with the life of Ramanujan and why he holds Ramanujan as one of all the time greats as a human being, as a pathbreaker, as a modern researcher, as a mathematician, and so on. He followed in the footsteps of enigmatic Indian Srinivas Ramanujan and explored his mathematical legacy. You might all have been wondering why is he in the session. He is intimately connected with Ramanujan, the greatest mathematician India has seen in the recent past, and how Ramanujan is relevant even today. We are honored to have you with us this evening, sir. Over to you, sir.
All right. Thank you very much. And good evening. If I've done my time conversion correctly, it's a little bit after 5:30 p.m. For me here in the United States, a little bit after 8 in the morning. And so I'm delighted that there was a point in time where we could actually be awake at the same time, allowing me to share with you this talk. I should say that there's a bit of audio static. So if you could mute your microphone so I can hear a little bit better, that would be very useful. Thank you very much. So this is a lecture that I like to give, and if you should be able to see on your screen this beautiful, famous passport photograph of Ramanujan. Underneath my title, Why Does Ramanujan, the Man Who Knew Infinity, Why Does He Matter? So growing up in the United States, my parents were Japanese immigrants to the United States. I first learned about Ramanujan on this date, April 7th, 1984. This marks a very important point in my life. And let me read to you the contents of this letter. This letter came to my house, addressed to my father, and the letter reads, "Dear Sir, I understand from Mr. Richard Askey, Wisconsin, USA, that you've contributed for the sculpture in memory of my late husband, Mr. Srinivasa Ramanujan. I'm happy over this event. I thank you very much for your good gesture and wish you success in all your endeavors. Signed, S. Janaki Amal." Now, in 1984, when this letter arrived, I was in high school. I, like many teenagers, certainly in my group of friends, we weren't thinking about trying to become academics or scientists. In fact, we weren't really great students. And to be quite honest, the last thing I wanted to do was be anything that my parents thought I should be. My father was a mathematician at Johns Hopkins, a university in the United States, and he desperately, and together with my mother, desperately wanted me to become a mathematician. And as I said, in high school, that's the last thing I wanted to be, because for me, it seemed to me that to become a mathematician, it was all about getting high test scores, memorizing lots of formulas, and doing well on, standardized examinations. It didn't seem like fun. Well, I'd never heard about Ramanujan when this letter arrived, and my father was brought to tears when he read the letter. And what I quickly learned was that to my father, there was an inspirational figure, this Ramanujan, whose ideas came to him from what they said were visions from a goddess. What I learned was this Ramanujan had left behind 3 notebooks that mathematicians through the 1980s continued to study, mining them for their deep results. And it turned out that these deep, beautiful results were so creative that they powered dozens, maybe even by that time, hundreds of mathematicians working in North America. And what I really found surprising was that when my father told me all of this, he then added that, and by the way, Ramanujan was a 2-time college dropout. And for me, that was the first time that it was made clear to me that being a scientist or being a mathematician had nothing to do with grades, had nothing to do with standardized tests. It had to do with the creative process. It was the first time I've heard from my father that doing science could be compared to the stuff of art and music, which everyone can find beautiful. And although it would take me many years to finally find that I was meant to be a mathematician, on this day was the very first time I learned from my parents that math could be beautiful and to look beyond test scores and grades. And that was very important to me at that age. If any of that sounds interesting to you, I wrote a book with my friend Amir Axel. He passed away before the book could come out. It's called My Search for Ramanujan. And so if you're interested in hearing how first the story of Ramanujan and later the mathematics of Ramanujan inspired me in my career, there's this book that we wrote called My Search for Ramanujan, which details that personal voyage for me. It's quite remarkable. It starts with me in elementary school and ends with the screening of the film The Man Who Knew Infinity. So quite frankly, at so many different points of time in my life, Ramanujan appeared, and he appeared in a way that I needed him. First as a role model as a high school student, later as a creative scientist, as a graduate student, and early in my career. And finally, now older, I'm in my 50s, now I'm in a position where I can use the story of Ramanujan to hopefully inspire others who, maybe like me when I was in high school, need some inspiration. Here's a photograph, together with the photograph of Ramanujan. Here is one of the movie posters that we produced for The Man Who Knew Infinity. And on the left, you see Dev Patel, who we cast to play Ramanujan. And on the right, is the famous British actor Jeremy Irons, who we cast to play G.H. Hardy, who I will tell you about. And at this early point in this talk, let me just say that as a mathematician, it came as almost like a miracle, a gift from God, say, that that popular culture, Hollywood, would call me to ask for help in making a film about a mathematician. If you're a math professor, you spend a lot of time alone or working with colleagues at chalkboards and with yellow pads of paper working out formulas. Never in my wildest dreams did I ever expect that Hollywood would call and say, we want to learn about the story of Ramanujan and we want to get the story right. Help us. So this was one of the most special events that have happened in my life. I still can't believe that it actually happened. And what I'm showing you here is one of my favorite photographs from our work on sets. This actually was used for posters in Australia, in the subways of Australia. And here you see me explaining to Dev how to teach the idea of complex analysis, or how to act as if you were teaching formulas from complex analysis. This lecture is called, Why Does Ramanujan, the Man Who Knew Infinity, Matter? And I'm going to offer many answers to that. Some of these answers you will know, and I think some of these answers, I hope, surprise you. Right now in 2020, this is a very traumatic time all over the world for many different reasons. We're struggling with the pandemic. We're struggling with, I don't really want to get started with all the things that we're struggling with. I want to focus on the positive. But it turns out, in my opinion, that Ramanujan matters for many of the reasons that we're still, that we struggle with today in terms of the promotion of science. So what you see in this photograph, I think, portrays an instance almost exactly 4 years ago where the story of Ramanujan resonated in the White House. So what you have here in this photograph is a photograph from a very important event that President Barack Obama held shortly before the last presidential election. We're about to have our next presidential election, and what I want to say is that when presidents end their term in the United States, or at least until now, who knows what the future will bring, but until now, it has been a long-held tradition that the outgoing president of the United States holds training sessions for the incoming, for the transition teams for the potential incoming president. And 4 years ago, we were trying to decide between Hillary Clinton and the current president, Donald Trump. And among the events that the president generally hosts, there are events that talk about the various arms of the federal government. And this photograph is from a Friday, the end of the week of transition events, and Barack Obama held a day on science. The United States has a major science industry regarding things like the CDC, which is very much in the news, the National Institute for Health, the National Science Foundation, the Department of Energy. Science is a big enterprise in the United States. And Barack Obama wanted to educate the transition teams for Clinton and Trump about the various and broad scope of these entities. And I was delighted that Obama asked us as the producers of The Man Who Knew Infinity to screen the film at the White House at the end of the Day of Science to be our social event. So why did Ramanujan matter? Because Barack Obama recognized that the story of Ramanujan speaks to everyone. The story of Ramanujan is, of course, one of science, but it also transcends that. It's the story of an Indian man who found a way to collaborate with a British man, two people who perhaps would have never known each other or should have never been able to communicate. And because of their various talents and strengths, despite the fact that they were from different countries, from different cultures, they came together and produced incredible science. And what Obama wanted to educate and inform the incoming potential presidential candidates was that So much of progress in science is international. It crosses the seas, it crosses cultures. And he wanted to use our film, The Man Who Knew Infinity, as a platform to emphasize that. I was delighted. That's one way in which Ramanujan matters. And as you can see in this photograph, I am giving a problem to the citizens of the United States of America, together with DJ Patil, who's very famous here in the United States. He was the chief data scientist in the previous presidential administration. On the left in red is Franz Cordova, the director of the National Science Foundation. And what may come as a surprise is that Hollywood actor Jeremy Irons came with us to the White House, and he said, I'm participating. I know the story of Ramanujan for the human aspect and the cultural aspect, and I agree that at this particular point in time, the message needs to get out right before the election. Independent of what you think about the outcome, I can tell you I was very unhappy with the outcome, and I'm looking forward to the next election. One way in which Ramanujan matters is that his story is quite international, and I wanted to share that with you. So there's several things about Ramanujan's life that you all know, so I'll go quickly through that. As was mentioned earlier, Ramanujan was born in 1887 in lush South India. He was born a Brahmin, and it won't come as a surprise that as a young boy, he was an outstanding student. If you visit Town High School in Kumbakonam, the principal will show you the awards that Ramanujan won. And because of his talent and his prowess as a student, he won scholarships to college. He did that twice. As a young boy, unlike me, when I was in 10th grade, I wanted to play video games. I wasn't thinking about mathematics. Unlike most of us, I think, Ramanujan did a lot of mathematical exploration on his own. And we learned that Ramanujan, in fact, invented much of trigonometry by himself by the age of 13. And who does that? That's really unusual. As a teenager, he received a gift from a friend. Here's a scan of a copy of one of these books. It was a book called A Synopsis of Elementary Results in Pure Mathematics by G.S. Carr. Not a very remarkable book. In fact, it was literally just an almanac, a compendium of formulas, a book that tutors used. And this book was later described in this way as enunciations of over 6,000 theorems, systematically and quite scientifically arranged, with proofs which are often little more than cross-references. But for whatever reason, this dry format, formula after formula after formula with very little text, inspired Ramanujan. It ignited his passion for mathematics. And as an amateur, he obviously concluded that the way that mathematics is done is by was indicated by the format of this book. So following the style in this book, he ended up doing his own research, and he ended up recording his own findings in his own notebooks, following a format quite similar to what you find in Carr's book. And I'm delighted to say that you too can go see Ramanujan's books. So here's a photograph from maybe 6 or 7 years ago. I'm with a Professor Raghuram who is a professor at IISER Pune. And here we are at the University of Madras's library. And the librarian brought out the 3 original notebooks in which Ramanujan recorded his findings. So it's really fascinating. If you ever get the opportunity to go see them, I do recommend it. And quite frankly, we shouldn't be allowed to flip through them, but I can't resist whenever the opportunity presents itself. I try to do that. So Ramanujan became obsessed with mathematics. It was an addiction for him. This was his raison d'etre. He started to spend all of his time doing his mathematics, and as a consequence, he flunked out of college twice. He was just literally unable to focus on subjects other than mathematics. And even in mathematics, he didn't do as well as he should, because the more elementary standard blasé courses didn't excite him. His passion was his own personal research. I like to say, certainly when I give lectures like this in North America, in the United States, to try to give an indication of what Ramanujan's life was like. And so I'd like to say that he probably spent a lot of time in his local temple listening to drums while he did his mathematics. This is not something that it would be understood in North America, but anyone who's taken a trip to India certainly understands the importance of the very rich and beautiful culture. And so I like to make that quite clear and emphasize that when I give these talks. One important fact is that Ramanujan was not lost to the world. He had people who supported him. And as I'm sure you know, despite the fact he was a two-time college dropout, he was given work as a clerk to help him get by. One thing that I need to emphasize is that nobody could comprehend his mathematics. One, he was an amateur. The mathematics that he did was completely of his own origin, or if you wish, were gifts to him from goddess Namagiri. And so it doesn't come as a surprise then that the formulas that he found would be expressed in ways that were very different from what anyone he knew around him could understand. So it's not an overstatement to say that no one could understand his mathematics. And to be completely honest, if we were to distribute Ramanujan's notebooks to math professors all over the world today, you'd also discover that well over 80, maybe over 90% of the faculty would have a very difficult time making sense out of his notebooks. His notebooks are full of formulas with very little commentary, and it would be a major challenge. And some of my friends, colleagues, people like Professor Bruce Berndt at Illinois, have spent their entire careers trying to go through and make sense of those three notebooks. So as was mentioned, I'd like to share with you some of the video clips from our film because I think they're quite interesting. And the first clip I want to share with you, it occurs very early in the film. At this point, Ramanujan has recently been married to Janaki Amal. Janaki was 9 when they first met. You'll see that by Hollywood standards, we can't have a marriage with a young girl. So our actress Devika Bise, looks nothing like 9. She's in her early 20s. And in this video clip, what we wanted to achieve is we wanted to make it clear to the audience that mathematics can be beautiful, something to be appreciated, something like art and music. And this is how we attempted to do that. Of course, this is part of making it very clear that Ramanujan was passionate about his mathematics, but was unable to share his mathematics with anyone else. So we wanted to get across this idea of desperation in Ramanujan, but also at the same time, that mathematics is and can be beautiful. So let me share that.
Go ahead. You can look. Please.
What does it all do?
It's like a painting, I think. Only imagine it is with colors you cannot see.
What good is that?
Not much for you, I'm afraid. But for me, it is everything. Maybe there is someone else who can see and understand it as well. And for them, it will be important.
Have you met them?
No, not yet.
I want to understand more than just colors I can't see.
What do you see?
Sand?
Yes? Imagine if we could look so closely, we could see each grain, each particle. You see, there are patterns in everything. The color in light, the reflections on water. In maths, these patterns reveal themselves in the most incredible form.
So I love this scene because we were fortunate to have a very gifted cinematographer who in fact won an Academy Award for some of his earlier work, and I think the beauty comes across quite clearly in this scene. So as the story goes on, Ramanujan was encouraged to reach out for help. Right, he was an amateur. He could have benefited from experienced mathematicians who could help guide him and lead him to rich problems. And he started to write mathematicians in the Western world. He finally wrote letters to G.H. Hardy, who was a professor at Cambridge. And he wrote in his first letter to Hardy these very beautiful, now famous words. I beg to introduce myself to you as a clerk. I've had no university education. I've not trodden through the conventional regular course, but I am striking out a new path for myself, and the results I get are termed by local mathematicians as startling. And from the film, the G.H. Hardy that we cast, it was Jeremy Irons. On the left here, you see one of the famous photographs of Hardy. There are very few photographs of Hardy. He was a very unusual figure. He didn't have many friends. He was an introvert. He was very smart. He was a distinguished mathematician. And here on the right, we have our photograph of Irons reproducing this pose. And I think he did a wonderful job. So what was in the letter that Ramanujan wrote to Hardy? So this lecture will have some stories, some mathematics, a little bit of everything. And I want to give some indication of why Ramanujan's formulas were so different from anything anyone had seen before. So Ramanujan claimed that the sum of the positive integers isn't infinity. It's not even positive. He claimed it equals negative 1/12. And at first glance, this looks absolutely absurd. In fact, it's difficult to come up with a statement that is more absurd than this. And so when Ramanujan would explain this to most scientists, they would write him off and dispense with him as certainly some sort of crank. But not Hardy. Hardy, as an elite analytic number theorist, actually understood that this expression, although clearly false, isn't completely false in a sense. It turned out that Bernard Riemann in the mid-19th century, who had in his work defining the Riemann zeta function, which is related to the Riemann hypothesis, was able to come up with expressions that would be analogous, directly analogous, if interpreted a certain way, with this expression. And Hardy was completely shocked that Ramanujan, without any knowledge of Riemann's work, would be able to devise and derive similar kinds of relationships because they, at first glance, seem crazy. So certainly Hardy was piqued by this observation. And what I want to tell you about now are some of the last formulas that appear in Ramanujan's first letter to Hardy, because these are the ones that really stood out, that shocked Hardy, because nothing in the literature by any mathematician ever before him resembled the formulas that I'm about to show you. So I can also make this a small teaching moment. I could ask you, just like in an algebra class, what is the value of the number x, where x is represented by this infinite fraction, 1 divided by 1 plus 1 divided by 1 plus 1 divided by, going on forever. So I don't want to take the time to explain how you would write down an infinite sequence of numbers that converges to this expression. Let me just jump to the trick. So in the denominator on the right-hand side, I made part of the denominator red. And if you notice, the part that is red is exactly an identical copy to the entire expression on the right. So the number you're trying to evaluate lives inside itself in this denominator. And so in particular, the trick is whatever x is, it has to be a solution to the equation x equals 1 divided by 1 plus x, because as again I said, the number in red is the whole x. So by high school algebra, you can cross multiply to get a quadratic equation. The quadratic formula offers two solutions. This number is patently positive, and so since only one of those solutions is positive, we find that x has to be -1 plus the square root of 5 over 2. All right, so that's a trick. And what we often do in mathematics is we ask whether some formulas or some equations are solvable because there's some trick, or are there general theories that extend way beyond the scope of the trick that remain true. And in this regard, Ramanujan made the most astonishing claims. So how would you possibly generalize this fraction? 1 divided by 1 plus 1 divided by going on forever. Well, one way you could do it is to try to make a function with a variable. And what mathematicians were trying to do at the time were things like this. Ramanujan defined a function r of q. He wasn't the first to define it. He's only the first person to ever prove anything about it, by means of this infinite fraction where the variable q appears in these numerators one by one with increasing power. And what is the point? The point is, if you substitute in for q the number 1, so if all of these powers of q are replaced by 1, what you get back is the original expression, which is related to this trick. And the problem that mathematicians were struggling with, and in fact, they would struggle with this almost throughout the entire 20th century, was, can anyone evaluate this function r of q for other values of q going beyond this trick? And nobody at the time that Ramanujan wrote Hardy had any idea of how to start. What would you do if you're a scientist or a mathematician trying to answer this question and you have no idea how to start? Well, what you might do is try to plug in different values of q. Instead of just plugging in 1, maybe you try a half. Maybe you try to plug in 1/3. If you're really ambitious, maybe you try to plug in 1/7. And I assure you that if you do that even to this day, you probably won't find an answer. We don't still know how to do that. That seems to be off limits. What is evidence of genius? What is evidence of creativity? Instead of plugging in 1/2 or 1/3 like I suggest, Ramanujan said, let's plug in for q e raised to the minus pi root n for any positive rational number n. And I ask, who in their right mind would think that the first things to try after plugging in 1 would be e raised to the minus pi root n, right? A number that has to be represented by a letter should indicate to you that that number is pretty complicated. This e is e of the natural logarithm. Pi is the usual pi, area of the unit circle. And on top of that, Ramanujan decided to raise e to the minus pi root n power. But what did he claim? Ramanujan's letter to Hardy ends with these formulas. This is his writing. Okay, this is a high definition scan of that letter. On the left-hand side, you find Ramanujan's notation for r. So this first line would be like plugging in e to the minus 2 pi for q. And he said, if you did that, you get this expression. And what I want you to notice is that my trick that gives the square root of 5 in this formula, Ramanujan recognized it wasn't the stuff of the quadratic equation, because these square roots of 5 appear in all of these expressions for every choice of n. It just turns out that when n is 0 and e to the 0 is 1, it just turns out when n is 0, the first expression you would write down is the one I showed you for the trick. But Ramanujan had the depth to understand that that had nothing to do with the special circumstances of the trick, that there was an alternative theory, which he says here, these values can be found if n is any positive rational number. he found a new method that no one had ever seen before that explains these expressions, and Hardy was blown away. So one thing that I want to say is that if my explanation doesn't astonish you, just focus on the fact that for someone like Ramanujan, some of the most beautiful numbers aren't 1, 1/2, or 1/3. They could be like e to the minus 2 pi, out of which he produced remarkable things. And that is evidence of genius. How would you know what to try? By the way, as you know, Ramanujan died at a young age, at the age of 32 in 1920. And this last claim that he made in his first letter to Hardy, made well over 100 years ago, was not completely rigorously proven and published until professors at Stanford did this only about 15 years ago. So Ramanujan died before he could fully explain what he already knew before he ever got a chance to work with Hardy. It would take the best mathematicians about 100 years to finally figure out what he meant. So here's a film clip that I really like. This is Hardy's initial reaction to the letter. Hardy had never seen anything like this before. And let this scene speak for itself.
You know, Littlewood, this year alone, I've received correspondence from those who profess to prove the prophetic wisdom of the pyramids, the revelations of the elders of Zion, and the cryptograms which Bacon supposedly buried within the plays of the so-called Shakespeare. But a letter from an ill-educated Indian clerk in Madras challenging assertions I made in the track series really takes the biscuit.
Well, I have to say, I've made similar assertions myself.
So you admit it?
But this was 3 years ago.
No, I'm talking about the letter. Bloody brilliant, I thought. I don't know where you got the postmark. Almost had me fooled.
I simply don't know what you're talking about.
Oh, come on. I'm not a complete idiot.
I don't know how to get this into your thick skull, but whatever it is you're talking about, I'm simply not involved. Play.
So, you've missed Hull? Not hungry. I tell you, there is a war coming, no doubt about it. Because we are being led like mindless, spineless sheep. No one bothers to question any of it. It's coming all right, you can smell it.
You're as paranoid as Hardy.
With all due respect, Bertie, you couldn't hold a candle. Littlewood, could I have a word?
Yes, of course. Integrals, infinite series, God knows what else. Oh, excuse me. I always forget you don't believe in a supreme being.
All right.
Well, this chap turns out to be genuine. You might have to reconsider.
Oh, he must be genuine. Who'd have the imagination to invent all that?
Well, I'm rather flattered you thought I did. These two infinite series are the more intriguing.
Yeah, they defeated me completely. I've never seen anything like them.
Well, it's deceptive. I'll wager the hypergeometric series.
A great Littlewood stumped. He's Hobbes class, I'd say. Being inexperienced, I would very highly value any advice you give me. Yours truly, S. Ramanujan.
What does the S stand for?
You can ask him yourself.
You intend to invite him here?
Oh, no. Much better. Let him rot away in his office in Madras.
So as you can see, Hardy at first thought the letter was a hoax, only to come to the conclusion that there was too much creative material in this letter to be any such thing. They really had to be the stuff of a very talented and creative mathematician. And so Hardy invited Ramanujan to study with him in Cambridge. At first, Ramanujan didn't accept, but finally he did accept. And the film clip I want to show you here, it represents the first meeting between Ramanujan and Hardy in Hardy's office, together with Hardy's mathematical colleague, John Littlewood, who you saw in the last scene. Oops.
Ramanujan, we decided that for the good of everybody, you should attend some lectures.
But I'm here to publish.
Yes, all in good time, I hope. But first we need proofs of your work.
It's really nothing to worry about. It's simply a question acquainting you with the more formal methods that will benefit our future work together.
I mean, we need a common language. You wouldn't expect us to converse with you in Tamil.
No, but you expect me to speak English.
Quite. So, there'll be plenty of time for publishing.
Sorry, but with all humility, how does anyone know that? I don't want this to die with me.
I assure you it won't.
Thank you, sir. But I have much more to share with you. As I told you, the letter only contained a small sampling of my discoveries. You'll see I have even found a function which exactly represents the number of prime numbers less than x in the form of an infinite series.
Exactly.
Yes, I thought if we were going to publish, it should be something groundbreaking.
Oh, this is most unexpected.
Hardy, this will take a lifetime.
Maybe two.
All right. So I showed you these last two film clips for a number of reasons. And for the film audience members who are not mathematicians, who might not be aware of the story of Hardy and Ramanujan, Ramanujan matters because it's the story of two very, very different people. As you may have picked up on in the last scene, Hardy was an atheist. He didn't believe in God. In fact, he was quite arrogant. He thought so highly of himself that he thought he was in a personal feud with God. This is one of those legendary facts about the enigmatic figure we have in Hardy. He had very few friends. He was brilliant, and he had such a high opinion of himself that he couldn't allow himself to believe that there was a God because he thought he could figure everything out. And so it was fun for him to tell his friends that he was always in a feud with God. But then in Ramanujan, we have a humble Indian who was a two-time college dropout, certainly not an elite Cambridge professor, who comes from a very spiritual very spiritual family. His mother sang in a temple. He was very well. So what's my point? Two very different people, different families, different religious beliefs, different educational background. Nothing about these two people should have suggested that they would be able to come together and produce beautiful mathematics. That human story matters. And the last film clip I want to show is the following. Because Ramanujan and Hardy were two very different types of people, and also because of the fact that Ramanujan was an amateur, he didn't know how people do mathematics, right? He didn't understand the need to write down rigorous proofs, complete arguments verifying one's claims, because for him, his strength was his intuition. All right. And well, intuition only goes so far. Your intuition can be wrong. And even for Ramanujan, it was occasionally wrong. And so one of the conflicts that one finds between Hardy and Ramanujan is how Hardy, who was meant to be the great mentor, the great professor, could bring along a student, despite the fact that Hardy himself knew that his student had far more talent. And if you're a professor or a teacher, you know what I'm talking about. How do you reach? How do you break through and help your student achieve great things? It doesn't always work. And in the case of Hardy and Ramanujan, this could have easily failed. And one of the scenes that I like very much in this film is the one I'm about to show you, because it shows Hardy finally recognizing how he could reach his student. So let me show you this scene.
How did you know that theorem?
It came to me. Mr. Hardy, I don't understand why we waste our time doing all these proofs. I have the formulas.
It's not that I can't see what you've claimed. It's that I'm not sure that you know how you got there. Or indeed that your claims are correct. There are subtleties which...
But they are right, sir. I have more important new ideas.
Yes, but intuition is not enough. It has to be held accountable. And a little humility would go a long way. Why do you think they want us to fail?
Because I'm Indian.
Well, yep, there is that. But also because of what we represent. Now, Euler and Jacobi, who were they?
Mathematicians.
Just names to you. Euler was the most productive mathematician of the 18th century. Most of his work done after he was blind. Jacobi, like you, was snatched from obscurity and was almost as impressive as Euler. Now, I think you are in their class. What they had in common, what I see in you, is a love of form. It's all through your notebooks. Let me ask you something. Why do you do it, any of this?
Because I have to. I see it.
Like Euler. Form for its own sake. An art unto itself. And like all art, it reflects truth. It's the only truth I know. It's my church. And you, just as Mozart could hear an entire symphony in his head, you dance with numbers to infinity. But this dance, this art, does little to endear us to certain factions who see us as mere conjurers. So if we are going to challenge areas of mathematics that are so well trod, we cannot afford to be wrong. I need you to attend your lectures, don't offend your professors, and keep doing your proofs. Otherwise, this experiment of ours will be doomed to failure. Come with me. I want to show you something. There are many ways to be honored in life. For us, being elected a fellow is certainly one, but in my humble opinion, to leave a legacy here at the Wren after we're gone is the greatest. This library houses the epistles of St. Paul, the poems of Milton, Morgan's Bible. But in my estimation, as a man of numbers, the pièce de résistance is Newton's Principia Mathematica. Now, just as Newton represents the physical aspect of our work, your notebooks represent the abstract. It took a long time for Newton to be proved, which is why we have an obligation to prove these. And if we do, I believe that one day, these notebooks will find their place here. Now, do you understand what's at stake here? Good.
So, as I was saying, it was very important for Hardy and Ramanujan to figure out how they could work together. And honestly, this was Hardy's responsibility as the mentor, as a professor. And how he finally got through to Ramanujan was when he realized that he had to explain to Ramanujan that his ideas would be important for the scientists of their future, and what the responsibilities are when you have the ability and talent to produce results that would speak to the science of the future. So the story of Ramanujan matters because it also ends up giving us advice about how to be a parent, how to be a teacher, a mentor, because two people who can help each other, and make no mistake, Ramanujan certainly also helped Hardy, have to know how to be flexible enough to work together. And this story represents that as well. So let me just begin to wrap up now. These things you largely certainly know. Ramanujan would end up producing great works in England. He wrote 30 papers, some with Hardy. He did this at a very difficult time, a time where England was in the midst of World War I. And make no mistake, India was just a colony in the great British Empire. It was horrible to be subjugated in that way. And so Ramanujan had many disadvantages that he overcame to do this great work. As a vegetarian, he would have struggled trying to just get proper nutrition while he was in England. And one of the triumphs, not only of his life, but just a triumph for humanity, was that despite these disadvantages, despite the fact that he was an Indian working in England, he was rewarded for his work, and he was elected Fellow of the Royal Society at a very young age. He was the first Indian scientist to be elected. I think he was the second Indian to be elected overall to the Royal Society, but the first scientist. And as you know, things would not turn out well for him. Ramanujan returned to India in 1919, hoping for a return to good health, for he had gotten sick in England, sorry. And this was not meant to be. Within the year, he would die in April of 1920 at the age of 32, almost exactly 100 years ago. One thing I would like to emphasize is his passion for mathematics did not escape him when he was sick. So even until his very last days, he continued to do work. He did work on what are called the Mach theta functions that I've spent a lot of time thinking about in my career. And he literally did that work from his deathbed. So I do, in wrapping up, want to close with a mathematical gem and some comments. So the last mathematical gem I want to share with you due to Ramanujan isn't technical at all. It's the stuff of child's play, the stuff of adding and counting. A function I like, P of n, is called the ordinary partition function in that it counts partitions. There's a technical definition for what a partition is, but an example is certainly good enough. If we were to represent the number 4 as a sum of numbers, including 4 itself, there are exactly 5 ways to break up the number 4. We won't count reorderings as a different partition. So if P of n counts the number of partitions, you can check me on this. Write down 8, 7 plus 1, right? 6 plus 2, all the way down through adding 8 ones. And if you count all the partitions of 8, you'll find that there's 22 of them. Here are the values of the partition function at the first few powers of 2, and you can find that these numbers grow at an incredible rate. If you don't believe it, do the 22, or try to have the patience to write down the 231 partitions of 16. By the time you've written only 30 of them, you'll realize that there really are a large number. So although the task of adding and counting seems simple enough, can you write down a formula that plugs in an n, that when you plug in an n, gives these numbers? Nobody knew how to do that. Hardy and Ramanujan were the first to figure out how to do it. They didn't get an exact formula, but they got what's called an asymptotic. It gives a very close answer, and it was amazing. They proved that the number of partitions of n is very close to this expression, 1 over 4n root 3 times e raised to the pi root 2n over 3 power. What this twiddle squiggle symbol means is that if you're to divide the right-hand side into the left and substitute in larger and larger and larger values for n, the numbers you would get out approach 1 rapidly. So these are good approximations for each other. The stuff of adding and counting can't be simple if this is how quickly those numbers grow. And there you see another e to the pi arising. So mathematically, this theorem was very important because the method that Ramanujan invented with Hardy is called the circle method, and is now one of the cornerstones of analytic number theory. People still are developing it today. In fact, I'm writing a paper right now this week where also using the circle method. And so let me just say, as a teenager, when I saw this crazy expression for stuff that comes out of adding and counting, that's when I recognized for the first time that all mathematical problems aren't expected to have a simple solution. So what do we learn from Ramanujan? We learn a lot of mathematics. So there are people who have won the Fields Medal for figuring out stuff of Ramanujan. The famous proof of Fermat's last theorem by Wiles makes use of mathematics that was invented to explain formulas of Ramanujan. So to mathematicians, Ramanujan is important. If you use a cell phone or you know what signal processing is, this is the language of receiving and sending messages by means of various sorts of waves. When you send these messages, errors naturally pop up. There's no perfect system. And what signal processing is the mathematics and the engineering related to information transmission and reception with the goal of minimizing error. And in 2016, my friend P.P. Vaidyanathan, who is a professor at Caltech, realized that in certain schemes in signal processing, there was a need for special functions that could be used to eliminate noise. And what he discovered is that the functions he looked for had been discovered before him by Ramanujan in Ramanujan's notebooks. And Vaidyanathan ended up winning the Kirchhoff Prize, the highest prize in this field, for recognizing that Ramanujan had already answered his question. The idea of Ramanujan for me is summarized in an article I wrote with Robert Schneider. Let me just read one excerpt from this. Ramanujan matters because he represents endless curiosity and untapped potential, which we all have to believe in to proceed in the sciences. Science usually advances on the work of thousands over generations, fine-tuning and extending the scope of understanding. But from time to time, creative fireballs like Ramanujan burst onto the scene, propelling human thought forward. Ramanujan may not have been educated in the usual way, but what he had in spades was ultimate and incredible creativity that we, the mathematicians of the last 100 years, have benefited from, because he showed us glimpses of theories that would take us over 100 years to develop. And in closing, let me just say Ramanujan matters because he is an iconic figure representing that talent is present all over the world. So together with the Templeton World Charity Foundation, we've been seeking this talent. So just like SETI, this is the search for extraterrestrial intelligence, right? As you may know, there are radio telescopes all over the world pointed up to outer space, hoping that an alien civilization will communicate with us one day, right? So far, that hasn't happened. But thanks to the story of Ramanujan, some seriously wealthy benefactors have supported a search on Earth, right? There's talent in our towns, our villages all over the world that are where people don't have the advantages that others do. And what we've been running is something called the Spirit of Ramanujan Global Talent Search. And what we have done is given scholarships and made innovative and inspiring research activities possible for students who otherwise wouldn't have that access. And so Ramanujan matters in this way because his story speaks to people who are in a position to help those who might not otherwise get these opportunities. So that's my lecture. I hope you found it interesting. Ramanujan matters for so many different reasons. And so with that, let me conclude my lecture.
Yes, sir. It was an amazing talk you've given in the evening, and I hope many would have.
I'm sorry, you've broken up.
And if you just spare a few minutes with us, we'll just have a conversation between you and us.
Sure.
Okay, fine, sir. Like participants, we are going to have a very interesting and very exciting conversation with Professor Ono through Google Meet and present the show in India. Professor Ken has a great life story which was highly influenced by the legendary mathematical genius Ramanujan. It's not every day you meet a top mathematician who was a high school dropout. There are some wonderful live sessions there for all of us here. Sir, my first question to you is that when did you first realize you had a talent and interest for mathematics?
Oh, that's an interesting question. We don't have very much time to go through that. There's two parts to that question. When did I first discover I have some talent for mathematics? Probably when I was, well, this goes back as far as I can remember. My parents like to tell the story that I could prove on my own that there were infinitely many prime numbers when I was 3 or 4. I don't know if this is true, but my parents like to tell that story. But I didn't like mathematics, and I didn't decide to become a mathematician probably until my mid-20s. I, like many others, went to a university, went to graduate school just because it was what I was supposed to do, the next step. But I don't think it was until my mid-20s when I really found my passion for mathematics. And so the moral is life is a long journey, right? And, you know, I could have ended up being many different things.
Okay, sir. Okay. Like in your recent book, My Search for Ramanujan, you record the struggles that led you to a career in mathematics. For those who haven't read the book, would you describe some of the background leading up to your doctoral work in mathematics?
I didn't understand that. You want me to explain background reading to prepare for graduate work in mathematics?
Up to your doctoral work in mathematics.
So I went to the University of Chicago, which is an elite university here in the US. And I just naively took the courses that we were expected to take. So this included abstract algebra, so of course calculus, abstract algebra, real analysis and complex variables. And those would be the customary courses you would take in college.
Okay, sir. Okay, right. You are a consultant on an excellent Ramanujan biopic, The Man Who Knew Infinity. How did you get involved in the film, and what was your experience working on the movie?
Oh, great question. Again, I could go on for hours. The director, Matthew Brown, emailed me 1 week before pre-production on the film started. And he emailed me and said, we should have a little meeting because I'd like to talk to you about how we could select formulas to appear in the film. So I was in Atlanta, Georgia at the time, and we had a short interview by Skype, very much like what we're doing now. It was supposed to be a short 15-minute meeting, and it turned into hours. And we started talking about Romanujan. We talked about the story of Romanujan, and the director quickly understood that I knew a lot about Romanujan, and so that I could be more useful than just selecting formulas. The next day, they gave me an offer. Can you come out to England right now to help us with pre-production? We'd love to have you. And then after 1 week helping with the art department and talking over the story, I was elevated to associate producer. And so it was, to make that long story short, it was all an accident. And it was one of the great accidents. I feel like Matt Brown writing me that email wasn't that different from Ramanujan writing Hardy in the first case, because certainly for me, no one you cannot be prepared as a mathematician to get a call from Hollywood saying that we want you to help us make a movie. It was exciting, and it still is exciting. It offers me lots, and has continued to offer me lots of opportunities.
Yeah, that was very brilliant, sir. Like another question to you, there was a great photo of you explaining mathematical concepts to Dev Patel on the set of The Man Who Knew Infinity. What was that experience like, and did you think he grasped the mathematics involved?
That was fun. Dev and I spent a lot of time with Dev and Jeremy, not only in the filming, but also during the promotion of the film. I got to travel to film festivals I met people like Johnny Depp. It was crazy who I ended up meeting because of this film. And I will say that both Dev and Jeremy are, of course, famous Hollywood actors, and they're famous Hollywood actors for a reason. They take their craft very seriously. So that photograph you show that I shared, that's pretty well known, was taken during my lessons. I gave them lessons on mathematics so they could see how I spoke. And I don't know how much they remember today, but yeah, we spent days where they were like my student. It
Fine.
was fun. Yeah.
That was fantastic, sir. And another question to you. You are a very active supervisor, I came to know, with 25 graduated doctoral students. What advice do you give your students about working in mathematics? And more generally, what advice do you give young people in high school or even younger?
So I do a lot of this. I don't have as much time as I would like to do this. Um, but there are a growing number of people who like to mentor talented students. Certainly, I know many in the United States. So with regard to the PhD students that I work with, I don't view this as school, right? We're all sharing this common search for truth, for knowledge. It's a challenge for us. And although I often use language like mentoring and professional development, the reality is that if you are genuinely in pursuit of difficult problems that you are fortunate enough to solve from time to time, the mentoring automatically takes care of itself, because it's a shared experience.
Yes, sir, that was
Yeah.
excellent. And here that you are not only an athlete but also an athlete. Could you just throw some views on it?
I used to race bicycles in my early 20s, and for a number of years, I was a triathlete.
Okay,
And
okay,
so I do cycle again almost 2.5 hours most days. So fairly fit, but I'm at 52 now, so yeah.
okay, right, sir. That was excellent. Next is, you stated that Ramanujan was your guardian angel, and how did he guide you throughout your life? And what are all some important lessons you learned, both from Ramanujan and from your experiences?
Oh, wow. We wrote a whole book about that. So
Yeah,
when I was in 10th grade, I ran away from home. I didn't like the pressure of having to perform on tests. I mean, let's face it, nobody enjoys taking tests, feeling like their life depends on the next test score. And when you're young, and this is true today in India, in the United States, all over the world, there's a lot of anxiety on the part of students thinking that the next test is somehow critical to one's future. Of course, it's good to get good test grades, of course, but is that the secret to happiness and ultimate success? Of course not, right? Ramanujan was a 2-time college dropout. I'm a high school dropout, right?
yes,
There's
yes.
right to the point. So as a 10th grader, it was important for me to know, not theoretically, but it was important for me to know that my parents respected someone who was a 2-time college dropout. I thought that was impossible, but they understood the importance of Ramanujan's work because it had played an important role in my father's career. In
Yes,
college, and then in college, I wasn't the best student. I was immature. I wasn't
okay,
honestly ready for that.
okay,
And one summer during my college years, there was a documentary that appeared on national television about Ramanujan. And it filled in a lot of the story that I'd only heard bits and pieces on from my father. There was footage from India. There was footage from Cambridge. And then instead of just being the story of a 2-time college dropout being successful, it was on screen. It was on color. It was somehow a little bit more human. It became more romantic. And that came on television just in time for me to do well enough in my courses at Chicago to impress some professors. That was very important. What would have happened if I had never seen that documentary? I have no idea. And then in graduate school, graduate school is hard. There are periods where you're absolutely demoralized because you're stuck on a problem. And in 1992, Robert Kennigal's book, The Man Who Knew Infinity, which is the source for the film, came out. And I read that with my advisor. And that gave me a lot of hope, because if Ramanujan could overcome all of these tremendous disadvantages to succeed, then who am I to struggle with these things that were much, much smaller by comparison? So I don't know what to say in terms of a guardian angel. And I could go on. My first big theorem, I really do have to tell you about this first big theorem that I proved, which I won a prize from President Clinton for, is also due to Ramanujan. My friend Bruce Berndt, who devoted his career to editing Ramanujan's notebooks, had come across some entries in Ramanujan's notebooks that he couldn't understand, and he thought that I could help him. So he emailed me some of Ramanujan's claims, and I thought right away, this is wrong. Ramanujan was usually not wrong, but he's wrong. I wrote Bruce back, he's wrong. But something bugged me. And I realized that maybe Ramanujan wasn't wrong. Maybe it was how I was trying to interpret his words that were wrong. And within a week, I came to realize what Ramanujan had actually meant. And because he was an amateur, I couldn't take his words for face value. I had to think about what his formulation might be. And it turned out there was a way to make it absolutely correct. And I built a little theory out of that. And it's one of my most highly cited papers. And somehow I ended up winning a prize from President Clinton, but it wasn't my work. It was for trying to figure out what Ramanujan left a glimpse of. So I don't know what better else to say. Yeah.
Well said, sir. And next is, what is one piece of work you worked on that was inspired by Ramanujan?
Well, there was that, my work on the partition function. My work in the Mach theta functions was more than inspired by Ramanujan. That was a 100-year challenge where we tried to figure out what his formulas are. And these now have implications in the study of black holes, right? Yeah. In India, maybe you know the name Ashok Sen. He's perhaps the most celebrated physicist in India right now. He's a professor at Harish Chandra Institute in Allahabad. Although he works in string theory, black hole physics, some of the works that people in my field do have now crossed fields, and they're now appearing in physics and black hole mathematics. And I find that very exciting. Who would have ever thought that Ramanujan's notebooks would have a bearing on string theory and those modern fields?
Fine, that was fantastic. And what are Ramanujan's lost notebooks? And what are some unique insights we can gain from them?
Well, Ramanujan's lost notebook, strictly speaking, was never lost. These were pages that were left behind when Ramanujan died, that Janaki Amal had forwarded to Cambridge University. G.N. Watson was supposed to go through and edit those notebooks. He never did. And when Watson died, these notebooks were discovered in his office. They were discovered in a box that was meant to be incinerated. A mathematician by the name of Atkin rescued them, and he saw to it that those pages were carefully preserved in the Cambridge Library. And there they sat for 30 years, and they were forgotten. The theory of the Mach theta functions, that's what's in the lost notebook. Without that lost notebook, the theory of the Mach theta functions would be really still a mystery today.
Yes. And next is moonshine theory. How is it related to mathematics?
Well, there's a problem in mathematics. So in mathematics, sometimes the objects we study are so complicated that we can't physically get our hands on them to analyze them. It's sort of like astronomy. If you want to study outer space, we neither have the resources nor the time to travel to all the places we wish to study. We have to infer properties of outer space by means of the light, the energy that reaches us that we can measure. All right. The similar phenomena holds in mathematics. We study groups. These are mathematical objects that were defined by Abel many years ago in the 19th century. And just like in chemistry, there's a fundamental periodic table of groups.
Okay.
And the largest of all the sporadic groups that exist is so complicated, it's called the monster, that the best way for us to study it is through what's called representation theory. This is like our telescope. And what moonshine is it's a device for making those calculations now possible. It's a very big thing. It's a very big field. It's making
That was really amazing, sir. And I've got many questions, but due to short of time, I'll just shorten my questions. Like with one or two, I'll just stop at this point. I want to ask you something that was 1920 and this was 1970s. That was 50 years. But you thought it had still validity or only historical curiosity?
The Ramanujan's lost notebook or his mathematics. Oh, this is no curiosity. People are using this in terms of the pursuit of gravity theory, quantum gravity. That's not curiosity. Engineers using Ramanujan's mathematics and signal processing. That's certainly not curiosity. That's engineering and science that we can all take advantage of today. The theory of Ramanujan graphs is the stuff of communication networks. That's being put to use, despite the fact there was never a need for that type of problem, that type of structure 100 years ago. So on the contrary, probably several hundred mathematical concepts and constructions bear his name for good reason.
Okay, fantastic.
But there are certainly some mathematical curiosities. 1729 is a mathematical curiosity.
Yes. And finally, why or should one necessarily have math phobia?
Nobody should have math phobia.
That's all.
Yeah. We recognize that that math phobia exists, but that's largely a function because of testing anxiety, right? People want to do well on tests. If you don't do well on a test, that gives a source of anxiety. But in the real world, the real world isn't made up of test after test after test, right?
Yes.
Challenges aren't laid out so nicely that they can be graded like our ordinary school exams can be. So I don't like that.
Well said, sir. And with this, I'll just conclude my conversation with you on behalf of all the participants over here in India. And my thing is that, dear participants, if you could want to know anything else from Professor Ken Ono, you can just raise your voice.
So I actually have to run because there's a Zoom session that is starting in 10 minutes. So
Fine. One or two questions, sir.
Yeah.
Dear participants, any questions? If you could want, you can just raise. Okay then, sir.
Okay. Well, thank you very much. Thank you for listening, everyone.
Thank you for being with us, and it's a wonderful opportunity to interact with you. It's my pleasure today, and I would really thank Professor Ken Ono for an initiative to outreach and showcase the art, beauty, aesthetics, importance, and applications of mathematics. I am extremely thankful to the participants who have been spending your valuable evening time with us to get some insights of Srinivas Ramanujan. I would also extend my heartfelt thanks to our management, principal, dean, and professor academics R&D for giving us permission and motivating us to organize such a wonderful public outreach event. Many thanks to Professor Michael Watt-Smith from France, who is also a world-renowned mathematician whose research has had a profound impact on number theory, for being with us this evening. Also, I extend my gratitude to all the school teachers and school students who have spared your time to take away fruitfulness of the program with you. Thanks to my coordinators, Mr. Karupusamy, Dr. P. Prabhakaran, Ms. K. Sangeeta, Assistant Professors of the Department, for helping to make this event a wonderful one. Thank you, one and all. And participants, I just thank everyone for sparing your evening time with us. Thank you, one and all. Sir, thank you so much for being with us and spending your valuable time with us. Thank you so much.
My pleasure. Good day. Bye.
Bye. Bye. Dear participants, kindly do fill the feedback form